Hello students, today we'll study about the velocity in the vectors. You are already familiar about the concept of velocity. So velocity, as you know, it is the vector quantity and it is the displacement in unit time. So this is a vector quantity and the speed. Speed is defined as the distance traveled in unit time. So that is a scalar quantity. We can also say that the speed is the magnitude of the velocity. In a very similar way, I can also say that, as you know, the distance is the total path length traveled by the particle, and displacement is the distance traveled in a particular direction so we can also say that the distance is the magnitude of the displacement vector. Now, one more concept that you have to keep it in mind here is that if any vector is divided by its own magnitude, we get a unit vector in the direction of the given vector. We are dividing any vector by its own magnitude means you are making the magnitude of the vector 1, and any vector with magnitude 1 is a unit vector. Secondly, if a unit vector is multiplied by a scalar a, then we get a vector whose magnitude is a in the direction of the unit vector. So this is just the opposite thing. Now I am multiplying the unit vector by a scalar a. That means I am making the magnitude of the vector a. So I will get a vector whose magnitude is a in the direction of unit vector. So keeping these concepts in mind, let us solve some problems. So come to the first problem here. A particle is moving with a velocity of 3I plus 4j meters per second. So find A part, the speed of the particle, then the B part, displacement of the particle in 2 seconds, and C part, distance traveled by the particle in 2 seconds. So let us come to the first part here, and we have already seen that the speed of the particle is the magnitude of the velocity. So here the velocity vector is 3I plus 4j. So how will you find its magnitude? Root of 3 square plus 4 square, which is 9 plus 16, root of 9 plus 16, that is root 25, that is 5 meter per second. Hence the speed of the particle is 5 meter per second. Then part B, displacement. Now we know that velocity is displacement divided by time. So displacement is velocity into time. So that is 3I plus 4j into 2, which is 6I plus 8j. So that is the displacement of the particle in 2 seconds. And finally the distance. So as we have seen already, the distance is the magnitude of the displacement. So the distance traveled by the particle in 2 seconds is the magnitude of its displacement. And the magnitude of the displacement vector is root of 6 square plus 8 square. That is 36 plus 64, root 100, that is the distance traveled by the particle in 2 seconds is 10 meter. So keep it in mind that the speed is the magnitude of the velocity vector and the distance is the magnitude of the displacement vector. So let us come to the next problem here. Now, second problem, a particle is moving with a speed of 20 meters per second in the direction in the direction 28I plus 96J. So find A, the velocity of the particle, B, the displacement of the particle in 10 seconds, and C, the distance traveled by the particle in 10 seconds. So first, now here the direction of motion is given, and also we know that the speed is the magnitude of velocity. So we'll construct a unit vector in the direction of motion, and we have already seen that any vector when divided by its own magnitude we get a unit vector. So this direction vector 28I plus 96J, I will divide by its own magnitude, that is root 28 square plus 96 square, which is 28I plus 96J divided by 100. This is the unit vector. So the velocity, we have already seen that if the unit vector is multiplied by any scalar, we get a vector whose magnitude is equal to the scalar. So now here the speed is the magnitude of the velocity. So I will multiply the unit vector by the speed to get the velocity. So 20 into 28I plus 96J divided by 100, which is 28I plus 96J divided by 5 meters per second, or that is 28 upon 5 I plus 96 upon 5 J meters per second. So this is the velocity vector. Okay, so let us come to the next part. Now in the next part, we have to find out the displacement of this particle. So again, the velocity is displacement divided by time, and hence displacement is velocity into time. So here the velocity vector 28I plus 96J divided by 5, and the time is 10 seconds given to you. So 28I plus 96 j into 2, that is 56i plus 192j, that is the displacement. And finally, in part C, you want the distance traveled by the particle, and as already we have discussed, the distance is the magnitude of the displacement. So the distance traveled in the time of 10 seconds is the magnitude of the displacement vector, which is root of 56 square plus 192 square. So just do that on the calculator. Root of 56 square plus 192 square, which is 200 meters. So that means the distance traveled by the particle is 200 meters. So in this problem, keep the concept in mind that any vector divided by its own magnitude is a unit vector. And when the unit vector is multiplied by any scalar, we get a vector whose magnitude is equal to the scalar. Okay, and speed is the magnitude of velocity. So on this, let me give you some problems for homework. Just try them out. So take down these two problems. These are for practice. So a particle is moving with a velocity of 9i plus 40j meters per second. Find part A, the speed of the particle. B, displacement of the particle. In 41 seconds, and distance traveled by the particle in 41 seconds. Okay. The second problem, a particle is moving with a speed of 20 meters per second in the direction of 8i plus 6j. Find first part, the velocity of the particle. Part B, displacement of the particle in 5 seconds and the distance traveled by the particle in 5 seconds. Okay, so just go through these concepts and do these problems on the similar lines by yourself. I'll see you in the next class. Enjoy the day. Bye.